Okay, folks, hello there. We're going to take a look at the examples here. First of all, starting off with the Pythagorean Theorem. We are going to solve this one, leaving our answer in simplified radical form. So let's show you how to do that. First of all, we have a right triangle. That's what we want to make sure we have. We want to identify which side is the hypotenuse, and so the 20 is the hypotenuse, so we're going to call that C. So if we think about a squared plus b squared equals c squared, we start off with a squared and b squared. It doesn't really matter which one of these we choose to be which, so we'll just say x squared plus 8 squared will equal 20 squared. The important part is to put the hypotenuse by itself. Okay, so let's simplify this. X squared plus 64 equals 400. If we subtract 64 from both sides, we get x squared equals 336. So therefore, x will be the square root of 336. That's our answer, but we need to simplify that in radical form. So to do that, we want to just start dividing out common factor, a factor of 336. Now, I don't really know what goes into 336. I have a suspicion that 6 goes into it. So let's go ahead and do 336 divided by 6 and see what we get. 336 divided by 6 is 56. So we're going to do 6 and 56 as two factors. And it didn't matter which two, you just keep breaking it down until you can't break it down any farther. 56 is 7 and 8. 8 is 2 and 4, and 4 is 2 and 2. So we end up with the square root of anything at the ends of the branches would work. So we're going to have 2, 2, 2, 2, 3, and 7. So 2, 2, 2, 2, 3, and 7 are at the branches. So now what I want to do is I want to take pairs. Anytime you see a pair inside a radical, that's a perfect square, and that pair can come out of the radical and become one value on the outside. So there's 1, 2 coming out of the radical. There's another 2 coming out of the radical. So those are gone, and that leaves us with 2 times 2, which is 4, and left in the radical is 3 times 7, which is 21. So there is the value of the value of x in simplified radical form. That's how we would do that problem, okay? In the next problem, it says classify the triangles as right, obtuse, or acute. I always want to start with the hypotenuse, and the hypotenuse is always the largest value, so that's the hypotenuse. Let's start by putting that on the left side, and we're going to square that, and then we're going to do 13 squared plus 84 squared, and we're going to figure out if a greater than, less than, or equal sign goes there. So 85 squared is going to be 7725. 7225, sorry. 13 squared plus 84 squared is also 7225. So there's an equal sign because they're the same. So this is a squared plus b squared equals c squared. So this is a right triangle. All right, let's try the same thing over here. Remember, the hypotenuse is the largest side. We start off with 14 squared. Does 14 squared equal 6 squared plus 11 squared, or is it greater than or less than? Let's find out. 14 squared happens to be 196. I know 6 squared is 36. I know that 11 squared is 121. When I add those together, 121 plus 36, I get 157. So 196, 157, this is greater than, so that's greater than. So I talked in the notes about what happens when the hypotenuse is greater. So I'll use my toothpicks like I did before. So basically it is saying that if this was a right triangle, that would be equal, but since the hypotenuse is larger, it pushes this larger, making this angle an obtuse angle. So this has to be an obtuse triangle. And those are your examples for section H1.